The step pyramid of Djoser stands as an architectural marvel in the Egyptian desert, a testament to human ingenuity that emerged nearly 4,700 years ago. This isn't just any ancient structure. It's the world's first large-scale stone monument and the prototype that launched pyramid building across Egypt. Before Djoser, royal tombs were simple rectangular structures called mastabas, but something revolutionary happened during the third dynasty of Egypt's Old Kingdom that would change architecture forever. Imagine Egypt around 2650 BCE. The unified kingdom was still relatively young, consolidating power under the divine rule of pharaohs. Enter Djoser, a ruler whose name would become synonymous with innovation. But the true genius behind the pyramid wasn't Djoser himself, but rather his vizier and chief architect, Imhotep. This man wasn't just an architect, he was a physician, astronomer, and later deified as a god of medicine. We rarely know the names of ancient architects, but Imhotep was so revolutionary that his name endured through millennia. What made the step pyramid truly groundbreaking was its ambitious scale and method of construction. Standing at approximately 200 feet tall with 6 distinct steps or tiers, it marked humanity's first attempt to build at such heights using stone. Previously, monumental buildings were primarily constructed from mud brick, wood, and reed, materials that simply couldn't withstand time. Imhotep's vision changed everything by stacking successively smaller mastabas on top of each other, creating that iconic stepped appearance. But the pyramid itself is just the tip of the proverbial iceberg. The entire Djoser complex spans over 40 acres and is surrounded by an immense limestone wall stretching nearly a mile in length. This wall features 14 false doors, with only one real entrance on the southeast corner. The purpose? Likely symbolic. In Egyptian beliefs, the deceased pharaoh needed to continue ruling and participating in religious ceremonies in the afterlife, and this complex served as his eternal palace. What's particularly fascinating is how this massive project represents a technological learning curve. The stone blocks weren't perfectly fitted like later pyramids. They were relatively small, irregular pieces stacked together, and then shaped to create the appearance of a smooth exterior. We're witnessing the birth of monumental stone architecture through trial and error. Beneath the pyramid lies an equally impressive labyrinth, a network of tunnels and chambers stretching for over 3.5 miles. This subterranean maze includes a central burial chamber where Djoser's remains were interred, along with various storerooms containing thousands of stone vessels and offerings meant to sustain the pharaoh in the afterlife. Many of these vessels date to earlier dynasties, suggesting they were collected from older monuments, perhaps the first archaeological collection in history. Recent excavations have revealed something even more intriguing. The massive trench surrounding the complex, approximately 164 feet wide and 65 feet deep, has puzzled archaeologists for generations. Initially assumed to be simply a quarry for the pyramid stone, careful measurements have shown that the volume of stone extracted from this trench far exceeds what was used in construction by nearly tenfold. So where did all that stone go? A controversial theory emerged in recent years suggesting this trench may have served a hydraulic function. Egypt, while predominantly desert, did experience seasonal rains and flooding from the Nile. Some researchers propose that this trench could have funneled and collected water, potentially creating a moat around the sacred precinct. More radically, some suggest it might have been part of an elaborate water-based transport system to move heavy stones. By flooding sealed chambers, workers could float massive blocks on wooden rafts to required positions, then drain the water to lower them into place. This hydraulic theory remains contentious among Egyptologists, but it highlights a crucial point. We shouldn't underestimate ancient engineering capabilities. These weren't primitive people fumbling with rocks. They were sophisticated problem solvers, developing innovative solutions with the technology available to them. The step pyramid didn't emerge in isolation. It was part of a broader experimental age in Egyptian architecture. Shortly after Djoser, the pharaoh Sekhemkhet began construction on his own step pyramid nearby, though it was never completed. At Maidan, we see another transitional pyramid that began as a step design, but was later modified with outer casing stones to create a true smooth-sided pyramid. These experiments culminated in the Great Pyramid of Giza, the perfection of the form. What's remarkable is how quickly pyramid technology evolved. In less than a century, Egyptian builders went from the experimental step pyramid to the mathematical and engineering perfection of the Great Pyramid. This represents one of the most rapid technological evolutions in ancient architecture. Moving beyond Djoser's innovation, Egypt's ancient mysteries extend far beyond pyramids alone. Consider the famous golden mask of Tutankhamun, discovered by Howard Carter in 1922. This iconic artifact has become the face of ancient Egypt, but recent research suggests it holds secrets of its own. Close examination of the mask reveals evidence that it might not have been originally created for Tutankhamun at all. The mask features pierced earlobes, which was unusual for adult men in ancient Egypt. Additionally, careful study of the cartouches, the oval name inscriptions, shows signs of modification. Some Egyptologists now believe this mask may have originally been created for another royal figure, possibly even Queen Nefertiti, and was repurposed after Tutankhamun's unexpected early death at around age 19. This theory gains credibility when we consider the rushed nature of Tutankhamun's burial. Despite the opulence we associate with his tomb, many elements suggest a hasty preparation. The tomb itself is unusually small for a pharaoh, and numerous burial items show signs of being repurposed from other royals. Tutankhamun died suddenly, possibly from complications of a broken leg combined with malaria, leaving court officials scrambling to prepare a suitable burial. The intrigue deepens when we consider that Tutankhamun's tomb might not be the only royal burial in that area. Ground-penetrating radar scans conducted in 2015 suggested the possibility of hidden chambers beyond the walls of Tutankhamun's burial room. While follow-up scans have yielded inconclusive results, the tantalizing possibility remains that Nefertiti herself, whose body has never been definitively identified, might rest beyond those walls. Ancient Egyptian technological capabilities continue to surprise modern researchers in other ways. Take the Dendera light, carved reliefs from the Hathor Temple that some interpret as depicting electrical lighting devices resembling modern bulbs. While mainstream Egyptologists view these as symbolic representations of lotus flowers and serpents, they've sparked debate about possible advanced knowledge of electricity in ancient times. Egyptian medicine was also remarkably sophisticated. The Edwin Smith papyrus, dating to around 1600 BCE, but believed to be based on material from 3000 BCE, contains detailed surgical procedures and case studies, showing a surprisingly scientific approach to medicine. Skull surgeries were performed with impressive survival rates, evidenced by healed trepanation marks on discovered skulls. But Egypt is far from alone in harboring ancient mysteries. Across the globe, archaeological discoveries continue to challenge our understanding of human capabilities. The Roman Empire, often celebrated for its engineering prowess, left behind puzzling artifacts like the dodecahedrons, metal objects with 12 pentagonal faces and varying sized holes on each face. Over 100 have been discovered across former Roman territories, yet not a single Roman text mentions their purpose. Theories range from measuring devices to religious objects to knitting tools, but their true function remains elusive. In South America, the Nazca lines continue to baffle researchers. These massive geoglyphs, only fully visible from high altitudes, depict various animals and geometric shapes etched into the desert floor. Created between 500 BCE and 500 CE, they required sophisticated surveying capabilities without the benefit of aerial viewpoints. How did the Nazca people plan and execute these massive drawings with such precision? Returning to Egypt, the question of how the pyramids were constructed has generated countless theories. The traditional view involving ramps has been refined over decades, with various ramp configurations proposed. Internal ramps, spiraling up inside the pyramid structure, have gained credibility based on small openings discovered in the Great Pyramid's corners. Water-based transport systems, as mentioned in connection with Djoser's complex, represent another possibility. What's clear is that these monuments weren't built through brute force alone, but through ingenious engineering solutions. The precision of the Great Pyramid, built with over 2,000 3 million stone blocks, averaging 2.5 tons each, and aligned to true north with an error of just 3/60th of a degree, speaks to sophisticated knowledge of mathematics, astronomy, and engineering principles. Recent excavations at Giza have revealed a workers' village with evidence of organized labor forces comprising skilled craftsmen rather than slaves. Well-preserved skeletons show signs of medical care, including properly set broken bones, suggesting these workers were valued members of society, receiving proper medical treatment. The organizational capacity required to feed, house, and coordinate these workers was itself a monumental achievement. Archaeological evidence indicates a sophisticated supply chain, bringing food and materials from across Egypt to support construction efforts. This administrative functionality represents an often overlooked aspect of Egyptian achievement. The influence of Egyptian pyramids extended far beyond their borders. Millennia later, ancient Nubian kings built their own pyramids, though smaller and steeper than their Egyptian counterparts. Later still, civilizations in Mesoamerica developed pyramid structures independently, though these typically served as temple platforms rather than tombs. The parallel development of pyramidal structures across disconnected civilizations raises fascinating questions about the universal human tendency towards certain architectural forms. As we reflect on Djoser's step pyramid and its legacy, we're reminded that innovation rarely happens in isolation. Every technological leap, from the first stone pyramid to the modern skyscraper, builds upon previous knowledge while pushing boundaries forward. Imhotep's experimental structure set in motion an architectural tradition that would define not just ancient Egypt, but influence building practices across civilizations for thousands of years. Perhaps what's most remarkable about these ancient achievements is how they continue to inspire modern engineers and architects. The precision, durability, and aesthetic impact of structures like the pyramids remain benchmarks of architectural excellence. Modern studies of ancient building techniques have revealed ingenious solutions to construction challenges that sometimes rival or complement our contemporary approaches. As archaeological technologies advance, from ground-penetrating radar to satellite imagery and digital modeling, we continue to uncover new aspects of these ancient sites. Each discovery not only fills gaps in our historical understanding, but often raises new questions about the capabilities and knowledge of our ancestors. The journey from Djoser's experimental steps to the perfected form of the Great Pyramid reminds us that human innovation is rarely a straight line. It involves false starts, abandoned projects, and evolutionary improvements, a process not unlike our modern technological development cycles. The pyramids weren't just tombs. They were technological proving grounds that pushed the limits of what humans could achieve with the materials and knowledge available. What began with Imhotep's vision for a stone monument ultimately culminated in structures of such precision and durability that they've survived for nearly 5 millennia. They stand not just as monuments to dead pharaohs, but as testaments to human ingenuity, ambition, and our endless drive to create something that reaches toward the heavens and defies time itself.